We're going to take a look now at object equality, which may seem like a bit of a digression, but in fact it plays well into the construction of sets, as we'll see at the end of this. So for primitive types, the idea of equality is fairly simple. If I give you two integers or two doubles, whether those two integers are equal can be seen just from their value. 5 is equal to 5 and 5 is not equal to 6. But for objects, equality is not such a simple concept. In fact, what do we even mean by equality? Do we mean A and B are equal if they're exactly the same object? Or do we mean equality in some deeper sense of the concept? Recalling how objects are stored, consider A and B, both having references to this object shown here that has two instance variables of value 5 and 10. Here, this diagram shows A and B to be exactly the same object. For example, maybe that object is a point, and the x and y coordinates could be 5 and 10 respectively. What if we have 2 points, each having the value 5 and 10? Here we show A and B referencing different instances of the point object, so they're not exactly the same object, but we might want to regard them as being equal in a deeper sense of the concept, namely because they reference the same x and y coordinates. If we care about equality due to them being exactly the same object, that's what the equal operator would tell us. So if we write A equal B, that's true if and only if A and B are exactly the same object, referencing exactly the same storage, exactly the same place where the point object is stored in the heap. If we care about a deeper sense of equality, and we almost always do, then we would use the phrase A dot equals B, which allows us to define what we mean by equality for each object on its own. To support the notion of equality, every object that we create has a method called equals, which takes in some generic object, which we'll call other. This equals method is available everywhere, just as the toString method is. We can define a toString for any object we care to, and that gives us information when we print out the object concerning its data. All objects also have the equals operator, and the default implementation is shown here, which basically decides whether the two objects are exactly the same. So if we don't change equals for a given object, it inherits this specific definition, which reduces to whether the two objects are exactly the same. That is, they live at exactly the same address. We almost always want to change this definition for objects that we define. For the string object we've been using, it's already defined for us because someone else developed that code, and the equals method for string tests first, do the two strings have the same length? If they don't have the same length, they can't be the same string. And if they do have the same length, a match is attempted character by character to see if they have exactly the same contents. So the string dog would dot equal another string dog, even if they're two different instances of that same string. For a color object, similarly, someone else has already written the dot equals method for us, and the color object decides equality based on the identical components red, green, and blue. So if two color objects have exactly the same red, the same green, and the same blue content, they will dot equal each other, and otherwise they won't. Now why do we do that? Well, we have color.black, which is defined as a constant inside the color class. If we construct our own color by giving it 0, 0, and 0 for red, green, and blue, that's essentially a black color as well. We would like for those two colors to dot equal each other, even though they don't equal each other. So the Java objects we've used so far already have reasonable definitions for equals. Examples include color and string. If we put such objects into a set, the dot equals method is what Java uses to figure out whether the element is already in a set. Recall that sets are not allowed to have any duplicates. Let's think about the contract for equality in the dot equals method. It's going to have several properties which help guide us in terms of deciding how to define equals for new objects that we wish to create. The first aspect of equality is that an object should always equal itself. This is called the reflexive property. So for example, x is always as tall as x. X has the same name as x. These relations are reflexive because they hold from x to itself. And we want A dot equals A to always be true. If I ask whether A equals itself, the answer should always be yes. Equality is meant to be symmetric. If you're a sister of Sue, Sue is a sister of you. If x is the same color as y, y is the same color as x. So these are symmetric relations because they hold in both directions. And we'd like it to be the case that if A dot equals B, then also B dot equals A. We would like this relation to be transitive. An example of transitivity is that if A has the same height as B, and B has the same height as C, then A and C are also of the same height. We would like it to be the case that if A equals B and B equals C, then A also equals C by transitivity. So our definition of equals has to obey these properties: reflexive, symmetric, and transitive. Another property we want equals to have is that it should be consistent. If I ask whether A equals B at one point in my code, and nothing changes, and I ask the same question a bit later, I should get the same result. So we don't expect equals, for example, to return a random result. It should be a result based on the contents of the objects under scrutiny, and it should return a result consistent with the values of those objects. Now, these properties make sense for us in everyday life. Colors and strings all have those properties. Moreover, if we ever ask whether A equals the null object, that is always going to be false. Objects of different types, if I ask whether a color equals a string, should also always be false. Now, the good news is that Eclipse has methods in it to generate dot equals automatically, but we have to tell it which fields matter to us in terms of equality. And this is something we should consider as we design objects. So let's take a look at the point object, and let's suppose that equality should be based on identical values for the x and y coordinates. So if I have the point 3, 4, it should dot equal any other point whose coordinates are 3, 4, and not dot equal any other point's coordinates. So let's look at the code automatically generated by Eclipse under these circumstances, and let's look at the code in terms of the properties I just talked about. So the first thing we see is if this equal obj, we should return true. This is exactly the reflexive property. If obj equal this, then the objects that are being compared for equality are identical. They're exactly the same object in the heap, and we should always return true in such a case. What if the object specified to the parameter is null? As said previously, we're under contract, under obligation to return false. The next test is a fancy way of asking whether the type of this object and the type of the other object are exactly the same. Are we comparing two colors, two strings, two points? If we're not, we're comparing, let's say, a color to a point, we have to return false. So if this.getClass, the type of this object, is not equal to obj.getClass, the type of the other object, we immediately return false and don't go any further. If we get to this point, then the object supplied for equality comparison with this is also a point object. Otherwise, we would have returned false by the line previous to this one. We therefore take the object and cast it as a point so we can look further into its values and decide whether it does dot equal this point. So you see point other is equal to the cast to point of obj. We can now look at the x and y coordinates of the other object just as we look at this one. So the next two lines compare this x and the other x, and this y and the other y, and if either of those disagrees, we return false. If we survive to the bottom line in the code, all the previous attempts to decide equality were unsuccessful, but what that means is we have an object that's the same type, both objects are the same type, and they also have exactly the same x and y coordinates, in which case we return true.